So these two ideas are connected. The idea of net and total area is connected to the physics of net and total distance. All right, so the area you were just doing has an application to the real world, to physics, when we talk about distance. All right, so an easy example is like my drive to and from school. Right, when I drive, it's about 3 miles. So my net distance, by the time I drive to school and back home again, my net distance is 0, because I've gone to school and I've gone home. So I've gone a positive direction and I've gone a negative direction. That's 0, because I end up right back where I started again. But my total distance, if I look at my odometer, is 6, because I've accumulated a total of 6 different miles. And so we talk about in physics words like displacement, okay, and words like distance. Yo, John, what you doing? What you doing? I can't tell what that is from here. My eyes aren't that good. You just were very intently reading. Go for it. All right, net, displacement. In physics, when you talk, if you're in physics, you already know what displacement is, if you haven't taken it yet. Okay, net displacement is net distance. It's the difference between where you start and where you end up. Okay, so between the starting and ending point. So if a track athlete does a 400, they pretty much end up where they started. So their displacement is 0. But you're not going to tell someone who's just run a 400 that they didn't run anything, even though their displacement is 0. They certainly ran 400 meters. They just ended up in the same place that they started. In calculus, we define displacement as the straight out integral. Actually, we're going to do it in terms of time, because velocity is always expressed in terms of time. So our axis is going to be time now as we move into more physics applications. So that's displacement, just straight out from A to B. If we want to do total distance, that's what we were just working on. It's the positive and the negative distance accounted for. And when we define that in calculus, it's A to B of the absolute value. And so you'll have to break that up just like you were doing in your homework, only now you get to use a calculator to do it, because we'll be doing more complex physical questions. All right, so let's talk about a spring that's bouncing and moving. We've done that before. And springs follow trig models. Okay, so a spring is bouncing according to the function with velocity 4 cos 2t. And the time interval is between 0 and pi. Whoops. Okay, so we just have a spring that's set in motion. The spring is bouncing up and down and up and down and up and down, so it's a physics problem. We know its velocity, but from its velocity, how can we figure out its distance? Okay, how much distance is it covering as it's bouncing? And so let's compare the net distance to the total. So we're going to compare the displacement to the total distance. And we can let our calculators handle this as well. So our displacement would be set up, if we had our calculator, from 0 to pi. And we're taking the velocity of 4 cosine 2t dt. And then we evaluate the antiderivative of that. And we can confirm that with our calculator. But this is something we don't need. It's not terribly complex. We can do the antiderivative. Okay, so the antiderivative of 4 cos is 4 sine 2t. But it's not just 4 sine regular t, it's 4 sine 2t. Now, when we had 2t in parentheses when we were doing derivatives, what did we always have to remember? Chain rule. And so, just like we had a chain rule for derivatives, there's an anti-chain rule for antiderivatives. So, in derivatives, you would multiply by 2. What do you think you do with the anti-chain rule? Divide, exactly. So, we're going to divide by 2. Plus the constant c going from 0 to pi. So, of course, we can reduce and then we can evaluate. So 2 sine 2 pi plus c minus 2 times the sine of 2 times 0 plus c. We know that the sine of the c's cancel out. Sine of 0 is 0, so this will be 2 times 0 minus 2 times 0. So the displacement is 0. So the spring hasn't gone anywhere. Comparing from its starting point to its ending point, it doesn't look like it went anywhere. If that was all you looked at, if you took a snapshot at the beginning, a snapshot at the end, you wouldn't think that it had moved. But when we look at the total distance it's traveled, we know that the spring has been moving. And so that would be set up as the integral from 0 to pi of the absolute value of 4 cos 2t. So now you need to remember a little bit about your ham and how does a cosine graph behave and when does cosine cross over the x-axis. And so you'd have to set that up. So thinking about cosine, we know that cosine is shaped like this. It's got an amplitude of 4 because of the 4 out in front, and it clearly crosses the x-axis. Its period ends at pi. And so you can use a little bit of symmetry to kind of help you figure out where it's going to cross. If it ends at pi, and it looks like that, then it's crossing the x-axis at what 2 places? Pi fourths and? Okay, it's crossing the x-axis at pi fourths and 3 pi fourths. So one way for you to take off the absolute value is, all right, I'm going to go from 0 to pi fourths, and I can use the positive. I could take off the absolute value. The negative section, if I take the absolute values off again of that, and switch my bounds because they're negative. So 3 pi fourths would be on the bottom as my bound, and pi fourths would be on the top. And then have a third to represent the last section, which is a positive section, so I leave the bounds in the normal order. So this is one way to do it. I will admit it's the longer way to do it. Does anybody see a quicker way? Okay, I can use symmetry. And if you recognize in the graph that by symmetry, this area is going to be the same as that area, which will then be repeated again on the other side, and then repeated again here. So I really only need one integral. Okay, I can use one integral. I can do this one and find this one, and then do what to it? Sure, there are 4 shapes of that. So if you take the time to think a little bit about symmetry, you can save yourself a lot of extra work. And so rather than having 3 separate ones, I can set this up as 4 times the single integral from 0 to pi fourths of 4 cos 2t dt. So I would have 4 times, and then the antiderivative, which we already did, was 2 sine 2t plus c, going from 0 to pi fourths. So that'll be 4 times 2 sine of 2 times pi fourths, which is no longer 0 like it was, plus c, minus 4 times the other one. This one is 0. I did already, I reduced it. It was, I have, right here, I'd already reduced that. I just took the same antiderivative I had from before. All right, so my c's are going to cancel out, and this 0 term will be gone. So I'm really just left with 8 sine of pi over 2. Okay, 4 times 2 are the coefficients, and then sine, reduce that. The sine of pi over 2 is 1, and so 8 is the total distance traveled for over this region. Okay, any questions on that one? Okay, our last one then. All right, now we're going to start with acceleration. So we're going to take acceleration, and I'm going to give it to you as 2t plus 16 over the quantity t plus 1 cubed. That's measured in meters per second squared. So that's what we're given. And the time interval is going to be time greater than or equal to 0. Now your first thing you might freak out a little bit about is wait a minute, that's not, what am I going to put on the top of my integral? Because if it's 0 the bottom, well, how do I know what to put on my top? That's okay, we'll get there. All right, first question. Solve for velocity. If the initial velocity, v sub 0, is -8 meters per second. All right, well, how do I solve for velocity if I have acceleration? Antiderivative. So I can do the antiderivative to this. So acceleration was given as, I'm going to rewrite it, and for our purposes, instead of doing 16 over t plus 1 cubed, I'm going to write 16 next to t plus 1 to the -3, because it's easier to do an antiderivative if it's written that way. So my velocity will be the antiderivative of each of those two pieces. So quickly, the antiderivative of 2t we all know is t squared. Now the antiderivative of 16t plus 1 to the -3 is t plus 1 to the negative what? We're going up. Okay, up to -2, we're adding 1. And then what do we have to do with our new power? Divide by -2, and we also have to divide by the anti-chain rule, which is just 1, because t plus 1, its derivative is 1, plus c. So my simplified equation for velocity is 16 reduced by -2, so that's going to be -8, and then I'm going to put the t plus 1 back in the denominator. But then I have a plus c. I know my initial velocity is based on time 0, and it should result in a value of -8. That's what initial velocity means. Plug in time to be 0. And so the velocity is -8 when time is 0. So 0 squared is 0. 0 plus 1 is 1. So this is -8 equals -8 plus c. So c worked out to be 0 in this case. So my velocity works out to be t squared minus 8 over t plus 1. That's also squared, still with a domain of t greater than 0. So we're just applying antiderivatives to a physics equation. All right, part B. What direction is the object going or in what direction is the object going at time 1? Well, the direction is directly connected to the velocity, just like the speed is directly connected to the velocity. So to find the direction, I need to know what the velocity is at that time. And so I'm just going to plug the number 1 into velocity. That's going to give me 1 squared minus 8 over 1 plus 1 squared. That's 1 minus 8 over 4. That's 1 minus 2, so that's negative 1. If the velocity is negative 1 meters per second, what can you conclude about the direction? It's going negative. Okay, so you would need to know negative either means it's going left if this thing is moving horizontally, or it's going down if it's moving vertically. So you'd have to read the context of the question to say the direction. So this question we're going to assume, I didn't specify, but we'll assume things are moving horizontally, and so we would conclude that it is moving left. So on an AP question, you would not just get credit for the word left, but you have to say it's going left because the velocity is negative. The value of the velocity is negative. All right, C. When will the object return to its starting position? This is sort of code. It doesn't use the word in it, but it's implied. All right, we talked about when you return to your starting position, that's called the displacement. And when your beginning starting position and your ending final position are the same thing, when you've returned, what do you know about the displacement? It's 0. So you have to set up, starting at 0, to some mystery time we don't know, because the question is when, of my velocity, which is t squared minus 8 over t plus 1 squared dt. When will that be equal to 0? And I've showed you how to solve that on your calculator. When you want to take an integral equal to a constant, you're going to do that in a y1 and a y2 on your calculator to find that time of when they would. So grab your calculator, make sure you're in radian, well, it's not going to matter for this problem, but make sure you're in radian mode. 2.587 seconds. So that is the moment when the displacement was 0. So our follow-up question is, now that we know that the displacement is 0, what's the total distance at that same point? All right, so then we would set up to convert it to total. You would set up from 0 to 2.587, now that you know it, the absolute value of t squared minus 8 over t plus 1 quantity squared absolute value dt. And the calculator can do that also for you. You don't have to worry about breaking up the integral. If you've got a calculator, let the calculator do it. Okay, so let's find that little spot right there. I'm going to do a second calculate. Oh, no. Okay, I don't want to wait for it to do it all over again. Okay, so then we're going to go, our math 9, we're going to go from 0 to 2.587, and then throw the absolute values in there. So that's under your math key, and it's under the second column, which is number, and then you'll grab the absolute values. Put in x squared minus 8 over x plus 1 quantity squared dx. So let the calculator do all the hard work for you. Just you got to remember to put the right bounds in and the correct absolute values. Okay. And then we'll let that think about its absolute value for a minute. Okay, there you go. There's your total amount of distance traveled. You've got an extra parenthesis in there. Okay, so that parenthesis right there, that's okay, because that just shut off your FN. So you've got 8x squared minus 8, and then you do want a parenthesis before the square. You don't want the parenthesis after. As soon as it sees, it knows that that shuts off that parenthesis. And the next one you do shuts off that.
kids report to the attendance office?
We will learn how to do that in chapter 7. We're not going to do that. We're just going to do regular signs. But so if the inside would have a 150, then you have to divide by
Tickets are on sale now for the last time in the SFC. If you want to go to the winter formal dance, tickets are on sale right
we'll get to
now.
that in chapter 7 too. Right now, the only things that will be in there would be a constant times t. Okay, so we only have to worry about the constants right now. We'll get to the other ones.
I think this is cosine like engine for maximum part. So it should be just like this. But
Also churches too.
it's really too high.
I've never had it.
So the graph should be like this, but this you just
That wasn't our function. Our function was, we had a 2 on the inside and a 4 on the outside. That was our function, not just cosine. So the 2x. It has to do with the period. Let me show you. Yeah. If you happen to finish it, I don't, you have somebody else?
I had it earlier.
Oh, okay. So just bring it
I'm
tomorrow.
sorry.
That's okay.
it's just like 2 divided by 4.
Okay, the period of the function is 2 pi over b. That's the period. Period. Okay, so cos x, which is what you were doing, has the period 2 pi over 1. That's why you're only looking c half of it.
Okay.
But ours was, yeah, period was 2 pi over 2, which means, so we were saying the whole thing.
Okay, and then so what about like what's the antiderivative for like this one? Is it just like write it again and then into times 3?
Mhm.
So it's 3 into like
Mhm.
okay.
Yeah, that was on the quiz.
Okay.
Yeah. You have to think about what the derivative was, so that you can figure out the antiderivative was. That one. Bye.